students, welcome back. Today we are going to start from question number 3rd. Last time we have finished till question number 2nd. We are doing of the miscellaneous exercise of chapter permutation and combination. Slowly we are reaching to the end of the topic. So let us see from question number 3rd. Question number 3rd is very important question, and in this question you will learn the new way of solving the questions of combination as well. Okay, so let us see what is given in the question over here. A committee of 7 has to be formed from 9 boys and 4 girls. Means total 9 boys are given and 4 girls are given to us. Okay, and from that group, the 9 boys and 4 girls, we have to select any 7 person. One thing note over here, that 7 person, when we are selecting, when we are forming over there, it doesn't matter who is coming first and who is coming at last. Okay, because we are forming a committee. So in committee, those who are coming first and those who are coming at last, the committee will not be different. The same 7 persons should be there. So here one thing very clear, the sequence doesn't matter. Now what they are saying to us, in how many ways can this be done when the committee consists of exactly 3 girls, at least 3 girls, and at most 3 girls. Means we have given that different conditions over here. So let us analyze each and every part and find out the solution for that. So first of all, we shall find out the part number 1. In the first part, they are saying to us exactly 3 girls. Exactly 3 girls. Okay, so let us see how we can find out. Now see, criteria is given that the girls would be only 3. So how many total we have to select here? 7. So the remaining person of committee of 7, we have to select from the boys. So here I have written in the table some entries are written. Since here only one case is possible, so I am marking as case number 1. But in second and third part, more than one cases are possible. Okay, so here number of ways for girls. Girls I am writing first. So here how many girls we have? Total number of girls are given to us as 4. You can see the total number of girls are given in the question as 4. And how many we have to select over there? Exactly 3. So we can say that the number of ways to select the girls, that will be 4C3. Now how many more persons required to select to form the committee of 7? We need to select 4 more persons because 3 already we have selected and 4 more are required. So that 4 more persons we can select from the 9 boys. So we can say that selection of boys can be done by 9C4 ways. And now the most important thing over here, only boys or only girls could not form a committee. They are the part of forming the committee. And I told always in the previous session also, I have told, when we are finding the combination or the permutation for a particular part and we are assembling all the parts, that all parts would be multiplied. So here total number of ways would be 9C4 multiplied by 4C. Okay, so this kind of table you can make in the solution and you can make in the examination as well. So now we can say that therefore total ways, once again we can write down here total number of ways would be equal to 9C4 multiplied by 4C3. Now let us simplify this one. Okay, so for simplification, 9C4, first of all we shall open. So 9 I will open for 4 places because 4 is coming in the suffix. So 9 I am opening for the 4 places. 9 into 8 into 7 into 6. Remember we have to open for 4 places. And in the upon, whatever coming in the suffix, that we shall keep as a factorial. Means we shall keep here factorial 4. So that will be 4 into 3 into 2 and then into 1. 4C3 I am not opening here. I am applying the formula complement rule 4C 4 minus 3. here one formula I have applied, we have done in the past. NCR is equal to NC n minus R. This formula we have covered earlier. So I just applied 4C, 4 minus 3. From 4 if I subtract 3, then also it will be equal to 4C 3 only. 4 and 2 will become 8, and 8 I have cancelled here. 3 ones are 3 and 3 threes are 9. So remaining is here 21. 7 and 3 I have multiplied by 6, multiplied by 4C1, and value of 4C1 means value of NC1 is always equal to N. Sorry, this will become 21 into 6 into 4. You can say here, since we can say that the value of NC1 is always equal to N. And now what can be the answer here? 21 multiplied by 24. Or else if it is better, this will be longer. We'll do one thing, 21 and 6 we can multiply first. That will be 126. And now 126 we can multiply 4. 6 4s are 24, 4. Carry 2, 4 2s are 8, and 2 10. Carry 1, 4 ones are 4 plus 1 5. So according to me, the answer is coming 504. Once you can check the calculation, okay. If it is required to make any correction, we can make it. So this way we can select the 3 girls and the remaining persons will be the boys. Now the important thing is coming now. This first part is just a rehearsal that we are doing the questions of combination, and such kind of question already we have finished in the exercise 7.4. Look at the part number 2nd. They are saying here at least 3 girls will be required. So what is the meaning of at least word over here? At least 3 girls. Okay, that I will show you first of all in the rough. See, meaning of at least is the minimum quantity you can take. At least, if I talk about the meaning of at least, means the minimum quantity you can take, and there is no limit for maximum quantity. You can go as much as possible. Okay, as much as possible you can go. For example, suppose if I say I have 10 pencils. Okay, and in that 10 pencils, if I say you can take at least 7 pencils. Okay, means I am giving you the flexibility, minimum 7 you can take. So what you will do, either you will take 7 pencils because minimum 7 I see, but if you apply your mind, you will say minimum 7 told, more than 7 also we can take. So you will take 7, or you can take 8, or you can take 9, or you can take 10. Okay, means more than 7, whichever are the possible ways, that all you can try. You can take 8 also, you can take 9 also, or you can take all the 10 pencils also. So at least means you start from that point and go till the highest level of point over there. Okay, for example, suppose if I say at most, if I talk about, okay, in the same question, at most, what is the meaning of at most? In the at most, there is, we shall start from the minimum, okay, and we shall go till the point wherever they are asking. Suppose if I say I have again 5 pencils over there, because at most we shall take little lesser quantity. At most 5 pencils. Suppose if it is given 5 pencils to us, and if they are saying you can take at most 3 pencils. At most 3 means you cannot take more than 3. Okay, so in that case what we will do, we shall start with 3, as we have started here from 7 only, but from 7 we reach till the highest value. Now here we shall start with 3 and we shall reach to the lowest value 3. Then I can take either 2 or I can take 1, and remember I can take 0 also. Sometimes the students forget about the 0. the person can say I am not taking any pencil, then it's okay, no problem. Okay. 3 or below 3, so below 3 0 also comes, so 0 is always considered in the case of at most. Okay, so if I say at most 3 pencils, then 3 you can take, 1 you can take, 2 you can take, or 0 you can take. Suppose for example, next time I have given you 8 pencils. Okay, and if I say at most you can take 5 pencils. Okay, so what you can do, 5 you can take, 4 you can take, 3 you can take, 2, 1 or 0 you can take. Okay, means from the 5 you have to start and come at the lowest level. Similarly, in the case of at least, whatever the unit is given to us, for example they are saying at least 7, or suppose if I say in this question, if it is given at least 5, at least 5 is given and 10 pencils we have given here. Okay, so we shall start with 5 and then we shall go to the last value, the highest value that we will examine till there. Okay, so 5 6 7 8 9 10 all we shall find out. Now the same technique we shall apply in this question also. Okay, but in this question one more new fundamental you will learn. Now let me rub this one first, then we can start the question. Yes, now let us see what can be the different cases are possible. What they are saying in the second part, they are saying at least 3 girls. Remember 9 boys are there and 4 girls are there. Okay, accordingly we have to maintain. This one I will take little down. Yes, so here first we shall write down the entry. Second point is given here, at least 3 girls. We have at least 3 girls required. Okay, what will be the number of boys we have? Number of boys we have here 9, and number of girls we have here 4. Okay, that is given to us, that is I written for your convenience. Now see what are the different cases are possible according to the at least that I am going to consider the cases over here. So the case number 1, first case. See, we have given that at least girl should be 3. So we shall start with 3. As I told you, at least, at most, you start from the given starting point. And then in the case of at least, you go till the highest level, whichever is possible. And in the case of at most, you come at the minimum level, the minimum value. Okay. So I am starting with 3 only. So suppose if I am selecting the 3 girls in a committee out of the 4. So that will be 4 C3. Then in that case I have to select 4 boys because committee is to be formed 7 persons, and here the total number of ways will be same as we got last time, 9C4 into 4C3. But here one more case could be possible because at least 3 I am starting, so I am going till the last value. So number of girls I am going to increase. Now this time I am taking the 4 girls. So out of the 4 girls, all 4 girls I am taking here. That will be 4C4. And in that case, if I am taking the 4 girls, then number of boys will be 3 because committee is to be formed only of 7 persons. Okay. So here I can say that in this case, the total number of ways will be 9C3 into 4C4. Okay, now you see out of these two cases there is no other case could be possible because already we have reached the maximum limit 4C4. We cannot select more than 4 girls because total number of girls are only given 4. If the girls are given 5, 7, 9, 10, then we can have the more and more possibility here. But since here the number of girls are only given 4, so this second case will be the last possibility and total number of cases can be 2. Clear? Now, the most important thing is there, as you know, the two part of one particular case or a particular combination we have to multiply. All the parts we have to multiply. But see, either the case number 1 will be performed, or I will say the case number 2 will be performed. Means when you are forming the committee, either you will take the 3 girls or you will take the 4 girls. Okay, because according to the situation, any one is possible. So case number 1 is one of the solution. Case number 2 is the another alternative solution. Means here in the case of, if I want to give the solution, I will follow any one particular way. For example, if you are going to this one particular city, then you will have the two ways. Either you will follow the way 1 or you will follow the second way. So same way here these two cases are there. Remember, again this will confuse you in the multiplication and addition. Okay, so that's why I'm telling you where to apply multiplication, where the different parts we are assembling at one place, then we have to multiply. But here you observe, here the different cases are there. This can be case number 1, I can say it can be the solution number 1, and this can be the solution number 2. Okay, so there are two different cases over there. So when the two different solutions are available, all the solutions we have to add. Okay, so here we shall add the case number 1 and case number 2. That is the only thing need to be understood. Once again, remember, if you are giving the different solution or a different cases over there, you will say either this can be a solution or this can be a solution or this can be a solution. So all the three solutions you have to add to give the total number of ways. So here I am adding it. We will say that therefore total number of ways is equal to 9C4 into 4C3 plus 9C3 into 4C4. Okay, let us simplify now. I will simplify in the same manner. Already the first part we have simplified, that answer we got as 504, but maybe the second part can come independently in the examination. That's why I am solving it in a proper manner. So 9 into 8 into 7 into 6 upon 4 into 3 into 2 into 1 into 4C3, as you know, I can write down as 4C1 also. Okay, 4 minus 3 plus 9C3. So we shall expand it up till 3 places. 9 into 8 into 7 upon 3 into 2. 1 we can leave it. And the value of 4C4 will be equal to 1, since NCN is always equal to 1. Okay, now do the cancellation as we have done last time. 4 into 2, 8. 3 ones are 3. 3 3s are 9. Okay, and here 3 ones are 3. 3 3s are 9. And 2 ones are 2. And 2 4s are 8. So now we can simplify it. This will be 21 into 6 into 4C1. You know it is 4 plus 4 3s are 12. 12 7s are 84. Right? So here already we got the value for the first part, that is 504. So 504 plus 84. So if I add 4 plus 4, 8, this will become, I think, 588 ways. Means I will have total 588 ways. By that I can select the minimum 3 girls. Minimum 3 girls means maybe I will be able to select 3 girls, or I will be able to take the 4 girls in the committee. Okay, because maximum 4 girls are only given in the committee. If they say the minimum 3 boys are required, then we will have lot of options. See, minimum 3 boys, then I will take 9C3, then remaining from the girls. Again 9C5, then remaining from the girls. 9C6, remaining from the girls. 9C7, remaining from the girls. 9C7, if I am taking, then no, there is no option available for the girls, means we are selecting the 0 girls from the committee. For example, if I am taking 9C6, then one girl from the committee we can take, okay. But I am telling you the number of options will increase if they give the same condition for the boys. Again here we cannot go till 9C9 because in the committee no 9 members are required. We have to select maximum 7. So if you are taking all the 7 boys, no problem, girls will be 0 in the committee in that case. But in the case of boys, the number of combinations will increase. Now see the part number 3rd. In the part number 3rd, see what they are asking to us. They are saying at most 3 girls. Okay, so let us see this question now. Let me take this table down. We have some space over here. Okay, so part number 3rd will mention first. At most 3 girls. At most 3 girls. Okay, now see, at most 3 girls means, therefore we can say that what can be the conditions possible? The number of girls can be here either 3 or we can go below 3, whichever can be possible. Therefore number of girls could be either 3 or what we can say 2 or 1 or 0. Okay, these are the possibilities. Number of girls can be 3, can be 2, can be 1, or as I told you earlier, it can be 0 also. So let us see the cases over here. Case number 1. First case, if the number of girls are 3, means out of the 4 girls, I am selecting 3 girls. Then same way from the 9 boys, I am selecting the 4 boys. And the first case is coming same as the part number 1. 9C4 multiplied by 4C3. Second one. Now if I say the number of girls are 2. Okay, so out of the 4 girls, I am selecting 2 girls. So in that case, the number of boys will increase. Out of the 9, I will select 5 boys. And in that case, the combination will be 9C5 into 4C2. Similarly, third one is the number of girls can become 1. So out of the 4, I am selecting 1. So in that case, out of 9, I am selecting 6 boys. So 9C6 multiplied by 4C1. And the last one is maybe the number of girls can be 0. Okay, because maybe no girls will be in the committee. So out of the 4 girls, I am selecting 0 girls. It means that in the committee, all will be boys. 9C7. So this will be 9C7 into 4C0. Now let us simplify this one. Again, now see, as I told you in the previous time, okay, these two are the parts and the parts I am multiplying, right? Now the number of girls can be 3, can be 2, can be 1 or can be 0. Okay, so these are all cases, first, second, third or fourth. So this can be solution number 1, this can be solution number 2, this can be solution number 3 or this can be the solution number 4. Suppose if we are asking you a solution of any question and we are saying that you give all the multiple ways what can by which methods we can solve the question. For example, suppose last year you remember we have done nearly 3 methods. One method was not in your syllabus, but suppose if we discuss. So 3 methods were there in your syllabus. Okay, one is factorization method, second one is formula method, and third one is the completing the square method. So there are three different methods is there, means either you can solve the question by this method, this one or that one. Okay, 3 methods were available. Same way here also in the committee either you can select the you can follow the first case or you can follow the second case or you can follow the third or fourth case. So when you are following different ways, that all the ways you have to add to find out the total number of ways. So here we shall write down at last, therefore total number of ways. Total number of ways is equal to 9C4 into 4C3 plus 9C5 into 4C2 plus 9C6 into 4C1 plus 9C7 into 4C0. Okay, let us simplify once again. 9C4 we can write down as 9 into 8 into 7 into 6 upon, same way it can be written as 4 into 3 into 2 into 1. 1 I am leaving it. 4C3 I am writing directly 4C1 plus 9C5, that is 9 into, okay, 9C5C. If I wish to open, then I will open it by 5 places. So that is better. We shall write down 9C5 first. 9C 9 minus 5. Okay. Complement rule. So it will become 2 over 4 over there. So it will be little easier for us. And 4C2, that we can write down into 4 into 3 upon 2 into 1, that is 2, plus 9C6, that we can write down 9C 9 minus 6, that will be little easier for us, and 4C1 is always equal to 4 because NC1 is equal to N. 9C7, so that we can write down plus 9C 9 minus 7 in the same manner, and 4C0 is always equal to 1. Okay, NC0, remember NC0 is equal to NCN is equal to 1 and NC1 is equal to N. That you remember. Now here we can cancel something, 4 and 2 again. I think we are cancelling third time the same thing here. 3 ones are 3 and 3 threes are 9. So this will remain as 3 into 7 into 6, that is 126, and 4C1 will become here 4. Sorry, I will write down little from downside. We can start from here. So this will be 1 into 6 into 4 plus, now see, that is becoming 9C 9 minus 5 will be 4. So now I am opening it up till 4 places. So 9 into 8 into 7 into 6 upon factorial 4. So 4 into 3 into 2 into, then here 2 ones are 2 and 2 twos are 4, that we can cancel. 3 into 2 will become here 6 plus 9C6. So 9C 9 minus 3 is becoming 6 over there. So it will be, okay, here I have done the mistake actually. 9C6 was there, so I have written 9C 9 minus 3. So here one correction will make, small correction. This will be 9C 9 minus 6. Okay, so it will become now 9C3. So we shall open till 3 places, 9 into 8 into 7 upon factorial 3, that will be 3 into 2 into 4 plus, then last one is 9C2. So we shall open till 2 places, so 9 into 2 upon factorial 2, that is 2 only, and 1 we can leave it. So here 2 and 2 got cancelled. Here 3 ones are 3, 3 threes are 9, and 2 ones are 2 and 2 fours are 8. Now finally we shall simplify. So 21 into 6, 126. So this will be 126 into 4. Okay, and this will be 4 and 2, again 8 is cancelled, 3 ones are 3, 3 3s are 9. So this will be again 21 into 6 into 6 plus 12 4 is 12, 12 sevens are 84. So 84 into 4 and then plus 9. Okay, I may be wrong in some calculation. Please check this calculation again carefully. So this will be, I think, 6 4 24 4 50 will 504 will only come, but once we can check, 4 2s are 8 and 2 10 and 4 1s are 4 plus 1 5. This is coming 504 plus 126 multiplied by 6 plus 4 4 the 16 6 carry 1 and 8 4 the 32 plus 133. So 336 and plus 9. So now finally it is coming 504 plus 6 6 are 36 6 carry 3 6 to the 12 plus 3 15 5 carry 1 and 6 1 are 6 plus 1 7. I think it is coming 756. Once we can check 6 to the 12 plus 3 15 5. Okay, 756 and 336 plus 9 we can add it here only. This will be 345. Okay, so once we can add all of them, 6 plus 4 10, 10 plus 5 15, carry 1 5 5 10, then 0 4 plus 7 11 plus 5 16. So according to me it is coming 1605. We can check it once again afterwards. If any calculation mistake is there, I will correct and then I will send you the notes. Okay, so here we can say that therefore total number of ways is equal to 1605. That will be your answer of part number 3rd. Our method is right. Calculation we need to check once again. Now let us start the question number 4th. In the 4th question, see what we have given to us. In the 4th question, they are saying if the different permutation of all the letter of the word examination are listed as in a dictionary, how many words are there in this list before the first word starting with E? Before the first word starting with E, okay, means we have to find out all those words which are starting before E. Means before E, which letter comes? Normally A, B, C, D, E. Okay, means A to D we can see. Before E, there are only 4 letters. A, then B, then C, and then D. Only this 4 letter comes. So we have to find out the word which starting with either A, with B, with C, or with D. But in the given word, do they letter exist? A is coming. Okay, you can see in the examination word A is coming twice. So A we can take, no problem. Okay, but B is not coming. So B is cancelled. Similarly, C is also not coming and D is also not coming. So we have available option over here only A. So basically the question is manipulated in such a way that we have to find out all the words which are starting with A, that we shall describe first. Okay, so let me rub this one first and then we can start our description as well as the solution. So see, here first we shall write down we required or we need to find those word which start with the letter letters comes before E. Okay, those letters which comes before E, from that the word should start. We need to find out such kind of word. Now we can say that since in the given word in the given word examination. In the given word examination, only letter A comes. Letter A is given. Letter A is given which comes before E. Which comes before E. Okay, so here what we will do, we shall find out the those letters which are coming, which are starting with we can say which are starting with A. Okay, so here therefore we'll write down, therefore we shall find those words which starts with E. Okay, so now let us see how we can find out. First of all, see in the examination word, now the word is going to start with A. So suppose if here I create some places 1 2 3 4 5 6 7 8, means the places I am going to create. One thing you observe here, the first place is reserved for A, so this is not required to arrange. We have to arrange the remaining places. So these are our remaining places that only need to arrange. So we can say that therefore letter A would be fixed at first place. Letter A would be fixed at first place. Therefore remaining letters, how many letters are remaining? See, in the word of examination, how many letters we have given to us? If I count 1 2 3 4 5 6 7 8 9 10 11, total 11 letters are given. Out of that, one letter is coming at the first place, that is A. So remaining letters are here 10. And in that, is it any repeating? Yes. In that, which letter is repeating? C. Actually, three letters are repeating here. A is repeating two times, then I is repeating two times, and N is repeating two times. So we can say that I, comma, N is repeating two times. Actually, A is also repeating two times, but since one A we have fixed at the first place, so remaining is only one A, and that cannot be counting in the repetition over there. So only I and N we can say repeating two times. Okay, and now here we shall apply the method of exercise 7.3 formula. If you remember, factorial n upon factorial p into factorial q into factorial r. Okay, that formula we have used, so same formula we shall use over here. Therefore total number of ways. And one more thing, you can check whether it is a question of combination or not. See, if you change the sequence of the letters, the word will look different. So here sequence matter. And in the combination, since we are selecting the person, the committee, or such kind of questions we have done, so if you change the sequence of the person, the committee will remain same only. Okay, so total number of ways will be here factorial 10, that is the value of n, and factorial p and factorial q, only two letters are repeating. So we shall write down the number of times they are repeating, that is factorial 2 into factorial 2. Now we shall simplify it. Factorial 10 we shall open here. We do not have any option. If it is possible to simplify now, I will simplify it. Otherwise, we shall keep it for the next time. 7 into 6 into 5 into 4 into 3 and then into 2. 1 I am leaving it. So factorial 10 I have opened till the last. There is no option. And factorial 2 is 2 only. So 2 into 2. Here this 2 and this 2 we can cancel. And one more 2 cancel can be with the 4. So remaining is here 1, 2. So I think it will be 10 into 9 8s are 72. Okay, 7 6 are 42. Again 5 into 2 10 and then 3 will remain. Okay, once we can check, 9 and 8 I have multiplied, 7 and 6 I have multiplied, 5 and 2 I have multiplied, and 3 I am keeping it as it is. So 10 into 10, that will become 100 into 72 multiplied by suppose 72 and 42. If I multiply, 3 to the 6 and 4 to the 12, that will become 126. So for 72 and 126 if I multiply, so suppose 72 and 126, let me multiply over here. 6 2s are 12, this will be 12 7s are 84, 7 6 are 42 and 12 2s are 24. So 4 plus 6, again 4 plus 2 2 67 7 carries 6. I think it is coming 9072. So according to me it is coming 907200. Okay, so please check once whether this calculation is right or wrong. I have done just roughly, so you can check once. Otherwise only calculation we need to correct. Okay, so we can say that here, therefore total number of ways, total number of ways is equal to 907200. This can be the answer. Okay, once you check the calculation. Now quickly we'll do the last question of today's, that is question number 5. Okay, the next question we'll do from the next time onwards. One minute. Sorry, we are at the wrong place. Let me go back. We have done the fourth question, then fifth. Yes, last question we are doing it. How many 6-digit number can be formed from the digits 0 1 3 5 7 9, which are divisible by 10 and no digit is repeated? Remember, here sequence matter, because if the digits are interchanged, the number would be formed different. For example, 100 and 001 are two different numbers. Okay, so first of all, you see what we have given in this question. We can say that total number of digits, total number of digits is equal to 0 1 3 5 7 and 9. This is given to us. This we can keep in the bracket. And total how many are there? These are 6. Total 6 digits we have given here. Okay, and how many digit number we have to form? 6 digit only. So number of places, or you can say digits required, that is required also 6 over here. So the meaningful combination will be here 6p6, directly we can find out. But here one condition they have given to us. However, it is given no digit is repeated. So no digit is repeated means repetition is not allowed. In that case, we shall use a formula of NPR. So that's why I said 6p6 will be the answer. But that will be a general permutation. Here one condition given to us, it is divisible by 10. So see, if I am going to make a 6-digit number and it should be divisible by 10, then one thing is very clear, that the number will occupy the unit place is always by 0. Then only we can say that the number will be divisible by 10, because then only it is divisible if 0 is coming at the last. So here we can say that the last place is fixed, that we need not to arrange. Second thing, 0 we cannot use it again because repetition is not allowed. So these are the remaining places available. How many these are? Total number of places are available here 5, and total numbers are also available here 5, because see, out of 0 1 3 5 7 9, 0 is utilized at the last place and it cannot be utilized once more. So how many numbers are remaining here? 1 3 5 7 9, 5 numbers are remaining and 5 places are only required to arrange. So that can be arranged by 5p5 ways. So we can say that since the number should be divisible by 10, therefore 0 is fixed at last place and repetition is not allowed. Repetition is not allowed. So therefore, what we can say, how many numbers are available? So we can say that therefore total numbers remain. How many total numbers are remaining here? That will be 5. And number of places required to arrange, that will be also 5. So now we can say that can be arranged by 5p5 ways. So here therefore total number of ways, that we can write down, total number of ways is equal to 5p5. Remember 5p5 why we used? Because repetition is not allowed. Now 5p5 we can write down by the formula of NPR, factorial 5 upon factorial 5 minus 5. Okay, so this will become factorial 5 upon factorial 0. Value of factorial 0 is 1 and value of factorial 5 is 120. So we can say that here at last, therefore total numbers formed uh, by given digits and divisible by 10. Divisible by 10 are 120. This will be your answer. Okay, so today first question, whatever the first question we have done today, it took lot of time. Otherwise the second and third question we have finished quite easily. Now some next questions are remaining, that I will take in the next session. Maybe 1 or 2 more sessions are required to finish the topic. You start preparing the class test for this chapter. Okay, thank you.